Greetings, young recruit! Today we begin your training to become number superhero.
Arithmetic sequence are like our super speed, a constant increase or decrease in our power.
Geometric sequence are our super growth, our powers to multiply rapidly.
And harmonic sequences are our super precision, a bit more challenging but more essential for mastering all our powers.
Unlock the secrets of the universe with Fibonacci. Discover the patterns of nature, arts, and design.
Are you ready to become number superheroes? Let's begin to our training. What is arithmetic sequence? It is a sequence in which term after the first is formed by adding a fixed number to the preceding term. The number added to each term is called constant. The constant number is called the common difference. To find the common difference, we just need to do a subtract a term before the preceding term. So here is the formula of the arithmetic sequence. So a sub n equals a sub 1 plus n minus 1 and b. When an represent the term and a sub 1 represent the first term of the sequence, and n represent the term number or the position, and d represent the common difference. So I have example here. So I have example 3, 7, 11, 15, and 19, and then find the 10th term. To find the 10th term, first we need to do is find the common difference. So our common difference is 11 minus 7 is equals to 4. So our common difference is 4, and then substitute to our formula. So our a sub n is 10, our a sub 1 is 3, plus n, our n is 10 minus 1, and our common difference is 4. So first, 3 plus 10 minus 1 is equals to 9, and copy common difference 4. Equals 3 plus 9 times 4 is equals to 36. So 3 plus 36 is equals to 39. So the 10th term of this sequence is 39. Next is arithmetic series. Arithmetic series is the sum of the numbers of an arithmetic sequence. You can get this by adding up the numbers of an arithmetic sequence. So here is the formula of an arithmetic sequence. So we have a sub n equals a sub 1 plus n minus 1 and d. I have example here. Find the first 50 terms of the sequence when the first term is 3 and the common difference is 5. So our a sub 1 is 3, our common difference is 5. So we need to find the 50 terms. So a sub 50 equals our a sub 1 is 3 plus our n is 50 minus 1, and our common difference is 5 equals 3 plus 50 minus 1 is equals to 49, and then 5 equals 3 plus 49 times 5 is equals to 245. Therefore, the sum of the first 50 terms is 248. And lastly, arithmetic mean. Arithmetic mean is the way to find the average of a set of numbers. It's the sum of numbers divided by the count of numbers. So I have example here. I have 4, 6, 8, 10, and 12. So to find the sum of these numbers, we need just to add them. So 4 plus 6 plus 8 plus 10 and plus 12. So it is equals to 40. So since they have 5 numbers, we need just to divide it by 5. So 40 divided by 5 is equals to 8. Therefore, the sum of the arithmetic mean is 8.
Now that you are already familiar with arithmetic sequence, let's now proceed to geometric sequence. In geometric sequence, we multiply by a constant value to get the next term. And that constant value is what we call the common ratio. Let's take a look in this sequence. The common ratio here is 3. Because to get the common ratio, we need to multiply any term to its preceding term. So for example, 6 divided 2 is equals to 3. And now, to get the next term of this sequence, we need to multiply 3 to 54. So 54 times 3 is 162. But how we're going to find the next term without having to list them all out? We're going to use its formula. A sub n is equals to a sub 1 multiplied by the common ratio to the power of n minus 1. Let's apply this formula to this problem. 2, 4, 8, 16, and find the 8th term. The first thing that we're going to do is to substitute the values to the formula. So, a sub 8, because that's the term that we're going to find, and 2, our first term, and 2, our common ratio, because 4 divided 2 is equals to 2. Then n again, so 8 minus 1. Then we're going to subtract this 2. So 8 minus 1 is 7. And after that, we're going to multiply 2 by itself 7 times. So the answer is 120. And the last step is we're going to multiply 128 to our first term, the 2. 128 times 2 is equals to 256. And that's the 8th term of our sequence here. After the geometric sequence, we have here the geometric series. Geometric series is the sum of the term in the geometric sequence. We have here two types of geometric series. The finite geometric series that has a limited number of the term. The next is infinite geometric series that continues indefinitely. Now, let's proceed to applying the formula of finite geometric series. The formula of finite geometric series is S sub n is equals to a sub 1 multiplied to 1 minus r to the power of n over 1 minus r. Let's apply this formula to this example. Find the sum of the first 5 terms of the geometric series 2 plus 6 plus 8 plus 54. Let's now substitute all the values in the formula. S sub 5, because that's the term, 5 term, is equals to 2, the first term, multiplied to 1 minus 3, our common ratio, because 6 divided 2 is equals to 3 to the power of 5 over 1 minus 3. The first step is we're going to multiply 3 to itself 5 times. So the answer will be 243. Then subtract this 2, 1 minus 3 is equals to negative 2. And after that, we're going to subtract this 1 minus 243 is equals to negative 242. Then multiply negative 242 to our first term, the 2. Negative 242 times 2 is negative 484. And after that, since we have number here, we're going to divide this 2. Negative 484 divide negative 2 is positive 242. And now, let's proceed to the formula of infinite geometric series. S is equals to a sub 1 over 1 minus r. We just remove the 1 minus r to the power of n. Because in infinite geometric series, it continues indefinitely. So let's try. Find the sum of the infinite geometric series 4 plus 2 plus 1 plus 0.5. So S is equals to the first term, 4 over 1 minus the common ratio 0.5. Then, let's subtract these two. 1 minus 0.5 is 0.5. Then copy the 4. So S is equals to 4 over 0.5. Then, divide these two to get the answer. And the answer will be 8.
Hi guys, for today, I will explain the Fibonacci sequence. So our first term is f sub 0 equals 0 and f sub 1 equals 1. So, ang gagawin natin ay pag-add lang. Basic guys, so 0 or first term, second term is 1. So 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, 8 plus 5 equals 13, and so on and so far. Ano lang guys, napaka-basic lang. So pagka may formula na, kung nahanap na natin, pag may nahanap na tayo, tulad nito, ang hinahanap natin is yung 6th term. So, ang gagawin natin ay itong formula. F sub n equals f sub n minus 2 plus f sub n minus 1. So, ang formula, ilalagay lang natin dito para may guide tayo. So, substitute lang natin. N is equals to 6 kasi yun ang hinahanap natin. So, f sub 6 equals f sub 6 minus 2 plus f sub 6 minus 1. So, minus lang natin. So, f sub 6 minus 2, 6 minus 2 equals to 4. And 6 minus 1 is equals to 5. So, ang ating fourth term ay 3. Our fifth term is 5. So, 3 plus 5 is equals to 8. So, ganun lang siya kadali. Ganun lang natin kadali makuha yung yung 6th term.
Now, we will discuss harmonic sequence. We will define, illustrate, and solve problems involving harmonic sequence. First of all, what is harmonic sequence? It is a sequence when each term is the reciprocal of an arithmetic sequence. Then, what is the formula of harmonic sequence? The formula of harmonic sequence is a sub n equals a sub 1 quantity n minus 1 times d. This is the formula of harmonic sequence. And now, we have 1/3, 1 over 10, 1 over 17, 1 over 24, and 1 over 31, and so on. And the term is 21st term. So now, the AN will become A21 equals A1 will become 3. Then, quantity 21 minus 1 times the common difference 7. And now, we will just copy the A21 equals 3. Then 21 minus 1 is 20. Then copy the common difference 7. And now, we will just copy the A21 equals 3. Then 20 times 7 is 140. So 3 plus 140. Then now, the 143 is our 21st term. And now, the reciprocal of 143 is equals to 1 over 143. Then this is the final answer of our harmonic sequence.